5 for homework 9. Okay, so it says when a small boat travels north at 15 kilometers per hour, a flag mounted on its stern forms an angle of theta equals 50 degrees with the center line of the boat shown. A short time later, when the boat travels east 24 kilometers per hour, angle theta is again 50. Determine the speed and the direction of the wind. There's two cases. One case when the boat travels this way. It goes this way. So for both cases, for case 1 and case 2, let's take a look like that. Case 1 and case 2. So this is 1, 2. Case 1, we have velocity of wind. So let's do this first. So overall, for both cases, we have velocity of the wind equals velocity of the boat plus velocity of the wind with respect to the boat. Case 1, we have two components. We have I and J component for the velocity of the wind. So we have velocity of the wind of X component plus velocity of the wind. Oh, my bad. Velocity wind Y component, and that will equal. This case, this is how we set up coordinates. So this is Y, this is X. So we will have 15 kilometers per hour for the J component, Y component. And we will have velocity of the wind with respect to the boat. For case 1, sine 50 equals I component minus velocity of the wind with respect to the boat. 1 cosine of 50. That will give us the J component. So in this case, for the flag, like this. So we have these two components. So positive X, negative Y. So this is what we got. So if we separate the two components, we get velocity on the X direction is 0 plus velocity of wind, boat, case 1, sine 50. We get velocity Y equals 15 kilometers per hour minus velocity of wind, boat, 1 cosine 50. So for case 1, case 2, similar process. Now the boat is traveling 24 kilometers per hour on the X direction. So if we do this, we'll get, let's just break it down from the beginning, just the X component. We will get 24 kilometers per hour. That's the direction the boat's traveling to, minus velocity. The wind, respect to the boat, case 2, cosine of 50. Velocity of the wind, Y equals 0 minus velocity and boat 2. 60. So now, after separating for each of them, we can solve for velocity of the wind, B1, B2, B3, and then the velocity with the x direction and y direction. So we can get the magnitude of the velocity. So in this case, we have 4 scalar equations. So we just plug and check in this case. So after doing so, we get the velocity overall. So this is for everything, both x and y component, 2 cases. So we will get velocity to wind with respect to B, case 1 will equal 28.027 kilometers per hour. So then after that, this one's 3.936 kilometers per hour. Velocity when x equals 21.7 kilometers per hour. Velocity wy equals negative 3.015 kilometers per hour. So having these two, we can get the angle as well and the magnitude of the velocity. So velocity of the wind will equal velocity then equals 1.68 kilometers per hour. And the angle theta will equal R10 BWY BWX equals 7.99 degrees. And that's it for this problem.